Hey there, science fans! Have you ever imagined a future where we can grow new organs right in the lab, where damaged tissues can be repaired with ease? Well, get ready, because that future is closer than you think, thanks to the incredible field of tissue engineering. We're talking about using living cells to create functional tissues and organs. It's like something out of science fiction, but it's real and it's already changing lives. Tissue engineering is like building with biological Legos. We start with a blueprint, then use special materials called bioinks to create scaffolds that mimic the structure of real tissues. These scaffolds act as a framework for cells to grow on. Once the cells are in place, they can multiply and organize themselves, forming new healthy tissue. This technology holds immense promise for medicine. Imagine being able to grow new organs for patients in need of transplants, eliminating the wait for a donor and the risk of rejection. Picture repairing damaged cartilage in joints, allowing athletes to return to their sports with renewed vigor. The possibilities are truly mind-boggling. Now, tissue engineering is a complex process requiring precision, sterility, and a whole lot of patience. But what if we could automate some of these delicate tasks? That's where our star player comes in, the R-TENG robot. This robotic marvel is revolutionizing the field of tissue engineering by automating key processes with incredible accuracy and speed. The R-TENG robot is like having an extra set of super steady hands in the lab. It can handle everything from mixing bioinks to carefully placing cells onto scaffolds, and because it's a robot, it never gets tired, never makes mistakes, and always follows instructions to the letter. Think of bioinks as the special sauce of tissue engineering. These incredible materials are carefully crafted mixtures of cells, growth factors, and other ingredients that support cell growth and differentiation. Getting the recipe just right is crucial, and that's where the R-TENG robot really shines. With its precise movements and controlled environment, the R-TENG robot ensures that every batch of bioink is perfectly mixed, guaranteeing consistency and reproducibility in tissue engineering experiments. No more human error, no more variations between batches, just perfect bioink every time. Section 5.3 Printing building scaffolds for cells to thrive. Now that we have our bioink ready, it's time to create the building blocks for our new tissue, the scaffolds. These three-dimensional structures provide the necessary support and guidance for cells to grow and organize themselves into functional tissue. And guess what? The R-TENG robot is a 3D printing master. Using a technique called bioprinting, the R-TENG robot can deposit bioink layer by layer, creating intricate scaffolds with incredible precision. These scaffolds can mimic the complex architecture of natural tissues, providing the perfect environment for cells to thrive. Section 6. Seeding the future. Placing cells with precision. Once our scaffolds are ready, it's time to introduce the stars of the show, the cells. This delicate process, called cell seeding, involves carefully placing cells onto the scaffold, ensuring they are evenly distributed and have access to the nutrients they need to grow. The R-TENG robot's steady hand and microscopic precision make it the perfect cell seeding assistant. It can place cells with incredible accuracy, ensuring every nook and cranny of the scaffold is populated, maximizing cell growth and tissue formation. Section 7. A cozy home for cells incubation and monitoring. Once the cells are seeded, they need a cozy environment to call home. This is where incubators come in. These high-tech chambers provide the perfect temperature, humidity, and gas composition for cells to grow and thrive. And of course, the R-TENG robot plays a crucial role here too. Equipped with sensors and imaging systems, the R-TENG robot can monitor the cell's progress inside the incubator, tracking their growth and ensuring they are happy and healthy. This real-time monitoring allows scientists to adjust conditions as needed, optimizing the tissue engineering process. Section 8. Precision and beyond. The advantages of automation. Now, you might be wondering why all the fuss about a robot. Well, automating tissue engineering with the R-TENG robot brings a whole host of benefits. First and foremost, it dramatically improves precision. Remember, we're dealing with tiny cells and delicate scaffolds here, and even the slightest tremor can mean the difference between success and failure. The R-TENG robot's robotic precision eliminates the risk of human error, ensuring consistent, reproducible results every time. This level of accuracy is simply not achievable with manual techniques, making the R-TENG robot an invaluable tool for tissue engineering research. Section 9. Efficiency is key. R-TENG robot speeds up the process. Time is of the essence in tissue engineering. The faster we can grow new tissues, the sooner we can help patients in need. And that's where the R-TENG robot's speed comes into play. This robotic workhorse can perform tasks much faster than any human, significantly speeding up the tissue engineering process. By automating repetitive and time-consuming tasks, the R-TENG robot frees up scientists to focus on more complex aspects of their research, accelerating the pace of discovery and bringing new treatments to patients faster. Section 10. Better outcomes, brighter futures, improving tissue engineering. Ultimately, the R-TENG robot's impact on tissue engineering boils down to one thing: better outcomes. By improving precision, efficiency, and reproducibility, this robotic marvel is paving the way for the development of more effective, reliable, and affordable tissue engineering therapies. Imagine a future where personalized tissues and organs can be grown on demand, tailored to each patient's unique needs. With the R-TENG robot leading the charge, this future is well within reach. Section 11. A glimpse into the future. Robotics and the evolution of tissue engineering. The R-TENG robot is just the beginning of a robotic revolution in tissue engineering. As technology continues to advance, we can expect even more sophisticated robots capable of performing even more complex tasks, with even greater precision and speed. Imagine robots that can not only build tissues, but also monitor their function and even perform minimally invasive surgeries to implant them. The possibilities are endless, and with robots like the R-TENG leading the way, the future of tissue engineering is brighter than ever. Keep those science brains buzzing.